Hello and welcome. This is day 22 of my Python learning mission, and as you can probably gather from the fact that I haven't posted since day 11, it has fallen off the wagon a bit. Sorry about that, but not that sorry because I've always been pretty clear that that there's more in my life than posting videos on the internet, as it should be. And lots of the other pieces got busy in the last week or so. So I've still been practicing on and off, and you can still, as before, you can find all my little problems that I'm working on bit.ly/Python learning folder. I'm up to like 50 different things in there now because I've been doing the Excel BI challenges practically every day. I missed one of them because it was late and it looked too hard. And I've been doing the Cameron Mumtaz challenges every day. I've done I've done 8 days of Advent of Code. I've done one esports thing, but that's not in here because it's not my file to share. So I've lost some time. I'm going to kind of extend my time a little bit. I'm going to give myself until the end of September to kind of try and get things back in the wagon. But after that, this is the Financial Modeling World Cup calendar, and it goes totally bonkers for the end of the year. And my work calendar also goes totally bonkers for the end of the year. So realistically, beyond the end of September, you're not going to get much more new, exciting Python content from me for a while, unless I manage to use it in the esports competitions, which we'll see. That's going to be challenging. But anyway, I've been doing lots of small things. I mentioned kind of a while back that I wanted to do something more in the way of a sort of project, like a real world thing. And the real world project that I want to talk about is basically recreating, but in a better way, something that I did many, many years ago, 7 years ago to be precise. You can still find it on my blog, although I gave up on my blog a lot faster, a lot sooner than I have made it on my YouTube channel. So there's not a lot else there. But an interesting project on what I called mapping divisions in the US Senate. It was inspired by a visualization that I saw in The Economist about how often senators voted together. And so basically the idea is if you go to senate.gov, you can find records of how all of the 100 sitting senators have voted on every bill back as far as 1989, so about 35-ish years of Congresses. And for each Congress, each session, so let's just grab one at random. Right here, there are 325 bills in the first session of the 115th Congress, aka the year 2017. And for each one, it'll tell you how every single senator in the chamber voted. And so what I did years ago was kind of grab a bunch of this data and do some visualizations. So for example, this was percent alignment with the parties, and the kind of point of this was, almost half of the senators voted with the opposing party a non-trivial amount of the time back in 1989, and less than 10% of them did in 2015. The kind of general recurring theme is, everything becoming more divisive. But the key piece, and the piece that I'm interested in trying with Python, was this visualization over here, which is what's called a multi-dimensional scaling. It's a statistical thing. It's a little wacky, but the idea is for any pair of senators, you can take a measure of the bills that they both voted on, what percent of the time did they agree? That gives you a measure of how, or actually, sorry, what percent of the time did they disagree? That gives you what you can think of as a measure of the distance in, the universe of disagreement between two senators. And the idea is that with some statistical techniques, you can find a 2D map where the distance between any pair of senators is a very, very, very good approximation to their distance in that sense. In other words, so this isn't actually an axis here. Think of it as just like a ruler. But if, whatever, let's say Joe Manchin to Lisa Murkowski is, I don't know, let's say about 40% on that, 30 to 40% on that ruler, that would tell you that those two senators disagreed with each other on about 30 to 40% of the votes. And obviously, it kind of lets you naturally see who's at the extremes of the parties, who's kind of closer to agreeing with each other, who disagrees most within the party, all that kind of thing. There's lots of interesting stuff there. So that's the project that I'm building toward. When I did this in Excel, I was able to do the kind of data gathering from the web, which I'll show you a little bit about. That's kind of the focus of today's video. But actually making the multidimensional scaling was extremely kludgy. I was definitely at the limits of what you can reasonably do with Excel. And basically the idea was I kind of initialized everybody to a random position, and then I took one senator at a time and used Solver to optimize their location. And so as I went through them and then kind of went back through them again and again and again until it stabilized, it sounds extremely unscientific, and it was, but it basically worked in the sense that it came up with a map that had an R squared compared to their actual distances between each other of percent of time they disagreed with each other, that was like over 99%. So it captured basically almost all of the disagreement between any given pair of senators was captured in how far apart they are in this chart, which is kind of amazing, as an achievement of statistics, and I guess also a statement about how little independent thinking there is on different issues, and how much people kind of vote in a couple of you know in a couple of patterns and groups. The fact that you can get this 300 400 dimensional data of all the different pairs of bills people voted on down to 2 dimensions with almost no loss of information. But I'm not going to talk too much about the politics of it. This is all quite dated anyway, except the bit about massively increased partisanship that has aged accurately. But I'm not going to talk any more about that either. Anyway, so part one, today's video, I want to talk about the web scraping element of it. So how do we gather this data? And then part two, I'll talk about a non-kludgy, awful way to use Python to do the multidimensional scaling. I hope. I haven't actually done that yet. I think I know how it's going to work, but we will see. You can see that all my recent searches are Python, Regex, fiddling. Anyway, all right, so what was I going to do? Oh yeah, I was going to go quickly to senate.gov. So the idea is you can go here, you can go to votes, and then for any given vote, you can pull up a page that shows, here's how every senator voted on that bill. It's mostly yays and nays, but actually depending on the bill, there are often like guilty, not guilty, and various other kind of weird things as well. And obviously someone can be not voting. So the idea is that we want to be able to come and like systematically gather this data for all the bills in a session, or maybe even more. I started off more ambitious, and then I had to kind of scale back a little bit. So let's come over here. This is my kind of web scraping start. So my starting point here was not here. It's only on some pages. Not here. Okay, I think if I go to the summary page for a year, then I can find yes, here it is. So there's one page here that has links to all of the sessions that there are votes for, and then within each of those, there are links to all of the individual votes. But they're also, each of these URLs is kind of structured. So this is, the 110th Congress, the first session, and the 442nd bill. So it's a pretty standard thing. Anyway, so my initial thought was, let's be totally scientific about this. I will start off, so first just import regex, because I'm going to need that, although I guess I didn't immediately realize that. I started off with a root query, which is just going to that first home page, and it's just a kind of one line. I don't know why Power Query is taking so long to load. There we go. It's just a one-line query, web.browser contents of this address, which is the website with the list of all the sessions. And that just gives you a big, massive HTML. And if you haven't seen this before, or if you're not familiar with HTML, just come over here and press Control U, and it brings you into View Source Code. And you can see there's like lots and lots of source code here for all kinds of things. But if I come back to this one, for example, in here I should be able to find the text of the links to each of those session lists, and here they are. So if I can kind of pull those out in the right way, then I'll be able to have the list of links, and within each of those links there will be HTML that will contain the list of all the bills in that year. I could pull all of those out, and then within each one of those there will be a list of senators and how they voted. So my initial kind of super optimistic hope was that I would scrape this page, get the list of URLs, then write a next query that would scrape each one of those, and then Python to get the list of, so that, this gives me the list of URLs for each session, and then by scraping each one of those I would get the list of URLs for each bill within each session, and then by scraping each one of those I would get the list of every vote for every bill for every session for every year that they have. That didn't work out for a few different reasons, which I will, whoops, that's not for you, that's for me, which I will kind of give you a sense of now. But so first things first, so I have this root query. It just dumps out all of the HTML. My initial thought was kind of inspired by this very handy video that Owen Price did on web scraping, where he used Beautiful Soup to pull out all the tables from like a Wikipedia article that had a bunch of tables in it. It turns out that this data is not, at least as far as I can tell, not as helpfully structured. So I wasn't able to kind of nab it with Beautiful Soup, but after playing around with it for a while, I figured out, okay, well, I know Python now, which means I know regex, so I can just find things that look sort of like this and pull them out. And that is basically what I did. So let's come back over here. I just have this root query not loaded that just dumps out piles and piles of HTML, and then from that, so I take root query and just iloc 00. I don't know why there's other stuff in there, but this the kind of top left cell basically of that is the text. So I guess it's just like a one element list, and you have to turn, anyway, it doesn't matter. So I wrote this this regex here, and basically the idea is I'm looking for href equals colon, and all this stuff is all the same for all of them, like /legislative /list /roll call lists, etc. So I just went out as far as legislative /lists, and then period plus just means period represents any character, so just some other stuff followed by this is the backslash is to escape, so that this is not a period representing any character, it is an actual period. So followed by .htm, and then followed by followed by a year, brackets, a number, the th, comma, and then either first or second. So here that is, so backslash d is any digit, so backslash d plus is any list of digits. So this is and the brackets around it mean it's a capture group. So I'm capturing this string, so the sort of legislative out as far as HTM. Then I'm capturing the year with this, so some sequence of digits. And then this is a little confusing because you've got brackets here for a capture group here and here. And then you've also got escaped brackets because we're also matching an actual bracket or parenthesis. So we're matching an actual bracket, and then inside that we have brackets meaning a capture group of some number of digits plus any two characters, because I wanted it to work if it was st or erd or anything like that, although in fact all of these are oh no, here we are, 101st and 2nd and 3rd. So this is the pattern here, is basically some digits followed by two characters followed by a comma, followed by some other digits, and that was what I was matching. A super handy thing for playing around with regex is just this site regex 101. So I'll just quickly show you. If you grab some bunch of text and oops, drop it in there, and then grab your regular expression and drop it in here, it will show you should show you. Oh, sorry, back up here where this is not quite behaving. Okay, I guess this is saying in this, it's expecting this character to be escaped. So fine, I will escape it. And then it's still not, I don't know why it's not matching it usually. It's better for me than this. No matches, okay. Let's try, maybe it's because I have it in quotes. That might be the issue. Yes, there we go. Okay, so now you can see it's saying, okay, so you're matching this whole block, and then it's highlighting in green the capture groups within that. So here's the first capture group, which is the address. Here's the second capture group, which is the year. Third capture group, which is the Congress. Fourth capture group, which is the session within that Congress. And you can kind of play around with your regex here to get it to behave, and then ultimately copy that back into Excel. So that's that, and that generates a list of the URLs for each, the URL and the year and the Congress and the session. So I guess if you don't know US politics, basically each congressional session lasts 2 years. So we re-elect the whole House of Representatives every 2 years, and like a third of the Senate every 2 years. And so, you know, I guess we're currently in the 118th Congress. But so, oops, sorry, I'm going to unfreeze so we can see a little bit more of this. So this is basically what it gives you. I've added votes separately. I'll talk about that in a second. So it gives you the URL, the year, the Congress, and the session. Now, the reason that I have this dumped out in a table instead of just in here, my hope was that I could have this Python regex thing dump the list of data into the grid. Then I just give that dynamic range a named range, and then use that as the start of another Power Query. It turns out that Python, I don't remember the exact issue with the interaction, but I was not able to do the back and forth like that. I think the issue is that Python cannot reference a Power Query query that pulls data from the Excel file you're in. So in theory, I could have, you know, had one file where I start off with just the single base URL and use that to extract these, and then saved and closed that file, and then had another file where I use Power Query to reference each of these and pull out the, you know, the list of vote URLs from there, dump that into the grid, save and close, and then start another one where I scrape each of those URLs, but it seemed overly convoluted. So instead, at some point, I dumped this list into the grid and just copy value, pasted it, made it into a table, and then just figured out how many votes each one of those had by yes, that was this. No, that's not this query. That's anyway. I basically did one scrape on each of these to figure out how many votes were in that session, just by figuring out, you know, the highest vote number among the vote URLs. So like I said, my hope was to go kind of back and forth in a lot of detail. Instead, what I ended up doing was basically using the fact that the vote URLs are very kind of consistently constructed. So in other words, if I know that there are 528 votes in the 2021 session, then I know that all the URLs will be of the form, you know, this, but with a different kind of 3-digit number at the end. And that pattern holds up over the entire period. So net, what does that mean I did? I take this list with the number of votes, I take it into Power Query, and I have this thing called all vote URLs. I've got a named range over here with the year in it. Again, my hope was to just pull everything, but it turns out that at, you know, 300 odd bills a year, 35 years, that's like 10,000 plus web pages to scrape. and that is quite time consuming for Power Query. So at some point I may attempt to leave it running all night and actually do that, but for now I've just restricted myself to looking at 1 year at a time. So what do? We say this is the year, this is the source table. So then I create this, oops, behind my face there. So then I create this query, which takes that table as a source, filters. So here I'm just using the named range called filter year, and this is as handy a way as there is to take data from the grid in Power Query. So you say excel.current workbook, filter for the name is filter year, take the content of that, column 1, line 0, which is all just a funny way of saying the number 1989. So we filter where the year is that. If I ever get to run it all night, I can just delete that line and everything else will work the same. Then I add a custom thing here, which is just a list of all the numbers from 1 up to the number of votes. Then I expand that into its own column. So now we've got, for the 101st Congress, session 1, which is 1989, vote 1, 2, 3, 4, 5, 6, 7, 8, and so on. Remove all the columns I don't need. So I just have the year, the Congress, the session, the vote number. Change the type of all of those into text because I'm going to combine them into a string. You can use, number.toText, but in this context, it's easier to just do it that way. So then we create the URL, which is just, most of it is the same, senate.gov, legislative, roll call votes, yada, yada, yada. Then you put in the Congress number, the session number, /vote, Congress number, underscore, session number, underscore. And then this was just a way, I don't know if there's a neater way to do this in Power Query, but just a way of padding out the vote number to 5 digits. So repeat 0, 5 minus the length of vote number plus vote number. And that gives you all of these URLs, any one of which you can kind of come over here and drop in. And this is, okay, these are all the votes from the from vote number 3 of the 101st Congress first session in 1989. Okay, so then finally we add to that something that scrapes the HTML for each one of these. Now, ideally, you would not need to load this in the grid because you can just have Python pull from an unloaded query. But this query is, even with just one session, this query is relatively slow. This will probably take me like 3 to 5 minutes to refresh. And so I don't want it, like one of the nice things about Power Query is that you can, rather than kind of regular Excel or Python or data tables where it's like calculation mode is either on or off, with Power Query I can kind of refresh any one table when I want to. I can refresh every table if I want to. There's no way, as far as I know, to say, let's do a bunch of Python, but don't recalculate just this one first cell. So in other words, if I had this as an unloaded query, which would in some sense be much more elegant so that there's not a bunch of unnecessary data spilled into the grid, then what I would lose with that is that basically that Python would then need to kind of re-update the query every time it ran. At least I think it would. I didn't try it out. So anyway, this gets me a big mass of HTML. Just a reminder that, this is, let's see, we'll take one of the actual votes. This is what it actually looks like. And the bit that I'm interested in is somewhere way down here. This would work. So this gives you the senator, D for Democrat, R for Republican, I for Independent, the 2-letter code for their state, and then how they voted. And so if I come back over here, I then created this data frame. So first we take the all vote URLs, which is the name of the Power Query query, also the name of the table, take all of that from year to vote number, headers equals true, and then I define a new column called votes. And for that, I'm going to use, again, regex find all. So find all matches of this pattern here. And again, the easiest way to build this pattern is to, take, sorry, wrong one. Take a bunch of this data, just start with the stuff that will match what you want, and then you can always add other stuff later. So here, let's start with this. Then let's say we want some characters. So A to Z plus, then a space, open bracket, then we want, well, I guess we can just say RRD RI, sorry, pipe for or, oops, dash A to Z plus, closing bracket, comma space, B, I guess, A to Z plus, sorry, A to Z, I need capitals and lowercase, so A to Z plus, and then that. So that's the sort of pattern you want to match, and you can see this generally matches, but you have to be careful. So here, for example, it does not match not voting because I'm saying in between, this bracket and this bracket, I only want letters. So I can tweak that to say, okay, add a space, and now we can see it's kind of matching everything here. But so here, for example, I'm saying I only want to match on letters, but this person has an apostrophe in their name. Some people might have spaces in their name. So I need an apostrophe, I need a space. I probably need a dash to be a little more flexible. So the good thing here is I can see 100 matches, and there are 100 senators in the US Senate. So that's a rough approximation of what might work. And then the thing to do is you want to mark a capture group around the bits that you're interested in capturing. So that pattern matches the name. I want to capture that. This pattern matches the party. I want to capture that. This pattern matches the state. I want to capture that. And then this pattern matches the vote. I want to capture that. So now you can see I've got 100 matches, and then within each of those, I've got green is the senator name, orange is the party code, purple is the state code, and other purple, pink, I don't know, is the vote. So that's approximately the regex I ended up using. Let's just go and see any differences with the actual one. So yeah, here I just used RDI. One kind of good sense check on these is, here, for example, I'm interested in the 1989 votes. So there's 312 votes in total. One quick check is just to say df.shape. And this should be 312 times 100. Wow, I guess maybe this is the first time I've called Python since I booted up the file. That is running very slowly, but it's warming up. Okay. So yeah, we can see there's eight columns and 31,200 rows. So you can see even just with one session, there's a good bit of data here. So let's just kind of walk through the code quickly. So I define the data frame as just, chunks of this. I think I dropped some piece of it. I took from year to vote num. Oh, got it. Yeah, okay. So then I added a new column called votes, and for that I used regex find all with this pattern that I just walked you through building, and looked for that in page 0 for each page in the HTML list. So again, you get the HTML text, you extract, or you get the HTML code, you extract the text from that, find all the matches. I wrap that in pd.unique because what I guess you don't see when you're matching it just on a sample here is that there's something like, votes by senator, and then there's also votes grouped by state or something else. So you basically get two matches for each senator. So where am I going? To avoid having issues with that later, I just wrapped it in pd.unique, and that makes sure that my counts are always 100 per vote. So that gives me the votes as a kind of list in a single cell. So then you can use df.explode votes, which is basically the equivalent of expanding a list into a full column in Power Query. So basically, where before we had um, like the equivalent of an item in this table with a list of 100 votes, now we have 100 rows of that, and each of these rows here repeated 100 times to go with it. Interesting, I seem to have broken something down here. Didn't think I changed anything, but we'll come back to that. So we explode that, and then we define 4 new columns, which is senator, party, state, and vote, just using list comprehension to say, votes.values. So votes is still, we've exploded it vertically, but it's still a list of 4 items, which is the 4 matches. So we just extract each of those into its own column and then drop the column called votes and reset the index. So net, that gives us a data frame. Let's just do the array preview of that. And so we have, the year is 1989, the Congress is the 101st, the session is the 1st. That's true for all of them. And then you have 100 rows for each vote, and then for each senator, what party, what state, and how they voted. Okay, my calc has gone away here, so I guess that was just busy or something. So the very, very first small step toward being able to do the multidimensional scaling is just being able to figure out for any given pair of senators, how often did they agree. So I've just got two senator names in here as variables, and then here's what we do. So we're saying send 1 votes is filter the data frame that we prepared up here, where the senator is this person, Mitch McConnell in this case. Then we take the vote column and we take the values of that. So we're just getting the list of their 100 votes in order as a list. And then we do the same thing with Senator 2. And then we, get that out of the way. Then we're going to do a list comprehension. So we're going to, for AB in zip, send 1 vote, send 2 votes. So this is just a way of iterating over the 2 lists simultaneously. We're going to say if A is equal to B, then 1, else 0. But we're only going to consider votes where both senators voted. So where not voting is not in the list of the 2 votes. And then we're going to wrap all that in np.mean to take the average of it. So of the votes that they both voted on, McConnell and Mikulski agreed 51% of the time. And so now I need to find an efficient way to calculate that percentage difference for every pair of senators, because I did briefly try just wrapping this whole thing in a kind of double list comprehension, for each send 1 in the list of senators, each send 2 in the list of senators. That was not an efficient way to do it, which makes sense. It shouldn't be. So I need to think a little bit about a neat way to code that, and then hopefully I'll be all set up to do my multidimensional scaling, and that's sort of my capstone project for this month of learning Python. That's all I got for today. Whew. That felt like a lot, but at least I haven't been totally slacking in the 10 days since I last posted a video. Hopefully I'll be back again rather sooner with the epic conclusion to this adventure, or at least another part of it. I don't know. We'll see how it goes. Thanks for watching. See you next time.